When I was doing the session, I made a mistake in doing this problem and couldn't find it. So let me show you this circuit, and we're going to look at it in a bunch of different ways so we can see how to solve it. All right, so first let's just use KVL and KCL. So I've got a node right here, and I have currents coming in, and I have currents, so two currents coming in, I and 1 amp, and one current going out, IX. So I know that I plus 1 has to equal IX. Okay, now let's do KVL. The right-hand loop is not really set up well for KVL because we don't currently know the voltage across the current source. So current sources are difficult to use in KVL, but we do know this one. So when you're doing KVL for a voltage source, if you are entering into, as you're going, making your loop, if you're coming into the positive side of a voltage source in your KVL, that you're going to add plus whatever this number is. Regardless of whether it's positive or negative, you're going to do plus that number. So if that number is 6, you'll do plus 6. If that number is negative 5, you do plus negative 5. If, when you're doing your KVL loop, you are coming into the negative side of the voltage source, then you do minus whatever that one is. So as I'm going around this loop right here, I'm coming into the negative side of the voltage source, so that'll be negative 12. And as you go across a resistor, if you're going in the direction of the current, as in right now I, as labeled, is going to the right, I'm going that direction, then you do plus IR, so plus 5I. Then as I'm coming down this middle branch, I'm going in the direction of IX, so I'll do plus 2IX equals 0. And then I'll just rearrange these two equations. I minus IX equals negative 1. That's the mistake I made yesterday, is that I left the negative out when I put it into the calculator. And the bottom equation is 5I plus 2IX. And then if I bring the 12 to the other side, it'd be plus 12. Multiply this top equation through, I'll multiply through by 2, and then I get 2I minus 2IX equals negative 2. And if I add these two equations together, I get 7I equals 10, or I equals 10/7, which is 1.43, so 1.43 amps. And then we know that I plus 1 equals IX, so IX equals 2.43 amps. Now, just to show you that this would have worked if I had done it correctly, if I go to the calculator and I go to solve those equations, and I put in a negative 1 right there. See, I minus IX equals negative 1. 5I minus, or plus 2IX equals 12. X equals 10/7, or 1.43, and Y is 2.43. Okay, so now let's look at it another way. So let's take the same circuit, and let's do mesh analysis. So with a mesh, I call this I1 and I call this I2. Now what's different here is that this middle branch is now made up of a combination of I1 and I2. The middle branch is I1 going down and I2 going up. And so the current going down that middle branch equals I1 minus I2, because it's got I1 going down and I2 going up. So now as I do my mesh from the left-hand loop, I'll have minus 12 plus, there's only one current going through that top branch, plus 5I1. There's two currents going through this middle branch, and so that is going to be I1 minus I2 times 2 equals 0. Now for the right-hand loop, this time I'm following the path going around with I2. So as I'm going around this path with I2, notice I'm going in a different direction. So I'm going up this branch, and going up this branch, that's going in the direction of I2, because I2 is going up, I1 is going down. And so when I'm following this loop, the current through this middle branch, I'm going to call it I2 minus I1 as I'm going around in the second mesh. So that middle branch is going to be I2 minus I1 times 2. And then as I'm coming to this current source, I realize that, hey, wait a minute, I don't have the voltage across this. And so I can't write the mesh the way that I thought I was going to write it. So I'm not going to do it like this. Instead, I realize that in this branch right here, I know the current is 1 amp going up. I also know it is I2 going down. So that means I2 has to be -1. So that is my equation for the second mesh. I know that I2 is -1. Then if I plug that in, I get minus 12 plus 5I1 plus I1 minus I2, so minus -1 will be plus 1 times 2 equals 0, or 5I1 plus 2I1 plus 2 equals 12. 7I1 equals 10. I1 equals 10 sevenths. So I have that I2, or I1 equals 10 sevenths, which is 1.43 like we had before, because that is what 10 sevenths is, 1.43. And then Ix, we know equals Ix is the current going down the middle branch, and the current going down the middle branch is Ix, and it equals I1 minus I2. So Ix is I1 minus I2, which is 1.43 minus -1, which is 2.43. Okay, let's look at this circuit yet another way, just to verify that circuit analysis works. Let's do nodal analysis. So if I call this V, call this ground, then going to the left, I would have V minus 12 over 5. Going down, I have V minus 0 over 2. And then to the right, I have a current coming in. In nodal analysis, currents coming in are negative, currents going out are positive. So that'll be -1 equals 0. Multiply through by a common denominator of 10, and I get 2V minus 12 plus 5V minus 10 equals 0. 2V minus 24 plus 5V minus 10 equals 0. 7V equals 34. V equals 34 over 7. 4.86. Now let's get our currents. I is the current going in this direction. And so Ohm's law tells me that I equals the voltage on the left, which is 12, because this is 0. So on the other side of this voltage source, it's 12. So as I'm going across this resistor, it's the voltage on this side, which is 12, minus the voltage on the other side, which is 4.86, over the resistance. So this is 8.86 over 5. Which is 1.78. What was I supposed to get? Let's get 1.43. So let's see, where did I mess up here? Of course I messed up somewhere. V minus 12 over 5, V minus 0 over 2, minus 1 equals 0. Minus 34 over 7, 7.14. So I subtracted wrong. Let's see. 34 divided by 7. Did I do that wrong? $4.85. Yeah, 34 divided by 7, 4.85, 12 minus, oh, yeah, I can't subtract. There's my problem. I can't subtract. 7.14, not 8.16. So this should have been 7.14 divided by 5. Yeah, I cannot do that. Yeah. 7.14 divided by 5. And 1.43. So I is 1.43. IX, if we look at this node right here, well, let's just keep doing this nodal analysis. So going down, that IX has to be V minus 0 over 2. V was 4.86. So if I take V divided by 2, I get 2.43, and that's IX. And I'm going to show you yet another way, just extra for experts. So this you have to you have to know how to do this in other courses. It's called source transformation. So you can change a current source and a resistor in parallel to a voltage source and a resistor in series. So if I have a current source and a resistor in parallel, where this is I and this is R, then as far as the rest of the circuit is concerned, this is equivalent to a voltage source and a resistor in series where the voltage source has the value of IR. Now, it doesn't help me find out anything about a current or a voltage in the thing that I'm transforming, but as far as the rest of the circuit is concerned, it acts the same way. So this would be 12, this is 5, and then I can replace this part with the resistor stays the same. The voltage source has the same polarity as the current source did. And this would be, this current voltage source would be 2 volts. And then this is equivalent to, that's 12 volts. And then just going to slide this one over here, I have 2 volts. 2 resistors are in series. So that's 7 ohms. Now if I look at this voltage source going from here to here, I'm going down, sorry, Kitty stepped on the keyboard. But he wanted to remind y'all that that was 2 volts. And so going from, I was asking what happens if you go from here to here. My kitty said you go down 2 volts. And then as you go from here to here, you go up 12 volts. So this is equivalent to going up 12 volts or 10 volts. So then I have, this is 10 and 7 ohms. The only thing that this is good for is what this tells me is what the current is in this branch. Because the current in this branch is going to be the same as the current in this circuit right here. So the current in that branch, which is I, is VR, or V equals IR, so I equals V over R, or I equals 10 over 7, which is, we've been getting all the time, is 1.43. Once I know that this is 1.43, I know I have 1.43 coming in, and I have 1 coming in, so going out, IX has to be 2.43. So that's the same circuit looked at in many different ways. And so now I can tell you that I'm quite certain that those are the correct answers.